Alright, this is the next kinematics problem we're going to look at. So let's read the question. It says a rocket is launched up with a constant acceleration. 4 seconds after liftoff, a bolt falls off the side of the rocket, and the bolt hits the ground 7.1 seconds later. And we're looking for the rocket's acceleration. So if I want to draw this out, I'm going to go ahead and just use a point particle as our rocket. So it's going to climb with an acceleration for 4 seconds. So it's going to have some height once it stops, or it's going to continue accelerating, but it's going to have a height after 4 seconds. Once it reaches that point, there's going to be a bolt that falls off. But the rocket is already accelerating, so the bolt is actually going to have some type of initial velocity, and then it's going to come right back down. You have to take into account the velocity of the rocket after 4 seconds for the bolt itself. Let's look at the height of the rocket after 4 seconds. So I'm going to use this equation. H of t is equal to the initial height plus the initial velocity times t plus 1/2 ay t squared, where in this case ay is our acceleration of the rocket. Our initial height is 0 because it's starting on the ground. Our initial velocity is 0, the instantaneous velocity. We don't know ay, but we know t is 4. So h of 4 is equal to 1/2 ay times 4 squared, which is 8 ay. What about the velocity after 4 seconds? Well, that's just going to be v of 4 is equal to the initial velocity, which is 0, plus our acceleration times the time it takes for that to happen, which is 4 seconds. So this is 4 ay. Using these facts, I can use a kinematic equation for the bolt to be able to solve this problem. So let's look at the bolt. I'm going to use this equation. H of t is equal to the initial height plus the initial velocity times t minus 1/2 gt squared. Objects naturally fall at the gravitational constant of negative 9.8 meters per second squared. That's just natural. In this case, our g is positive because I already put in a negative into the equation. So we're just going to use positive 9.8. Well, after some time, in this case 7.1 seconds, our height is 0 because that's where the bolt is. So this is going to be 0 is equal to, what's the initial height? Well, that's just going to be 8 ay. That's the initial height of the bolt when the rocket is accelerating for 4 seconds. What about the initial velocity? Well, that's just 4 ay, and we're going to multiply that by t. In this case, 7.1. And then I'm going to go ahead and subtract 1/2 our gravitational constant times 7.1 squared. That's the time for the bolt. So now our bolt equation is in a function of the rocket acceleration. So now we can actually find ay. So let's move everything to one side. We're just going to move the 8y and the 4ay times 7.1 to one side. And I get negative 36.4 ay. And this is going to equal, and then let's plug this into the calculator. Let's see. 7.1 squared. Okay, I'm getting negative 247.009. Now, dividing these two, we're going to be able to get our AY value. In this case, I'm getting 6.79 meters per second squared. So what happens is, when the rocket accelerates, so when the rocket goes up, it has to be higher originally than negative 9.8 meters per second squared. So in reality, the initial takeoff is higher than this 6.7 meters per second squared in reality. You have to be able to lift off first. Once you're at that point, once you lift off, you can have a constant acceleration. That's how acceleration works with rockets. So this concludes the this kinematics video. If you have any questions, just go ahead and comment on this video, and thank you.